we are going to talk about the elementary applications in differential equations. So part one will be about solving problems involving growth and decay and Newton's law of cooling. So we will apply variable separable method in solving elementary applications of the ordinary differential equations. Let's start with the growth and decay. Now for our first application, elementary application, so we are going to talk about growth and decay. Okay. So in differential equation, so these are the two equations, or maybe we can say only one equation for solving problems in growth and decay. So it says that the rate of growth, say for instance, um, number of bacteria is proportional to the number of bacteria present. So this is actually a differential equation of the growth. Okay. So for decay process, so you have the negative sign for your k, so that when you solve for k, it will be positive. Okay. But in my examples here, I'll be using one equation only. So I'll be using this equation. The rate of growth or decay is proportional to, okay, the number of substance, or maybe the mass of a material if it's decaying, or it's the number of people if it's about population. So I would be utilizing this equation. So what will happen? So if it's growth, the value of k is positive if I'm going to use this equation, and the value of k will be negative if it's decaying or decay, or it's a decay problem. Okay, now let's proceed to the next page. So this figure is, or shows you the exponential growth. So, and for decay process or for decay problems, so this is the illustration for the decaying process. Now let's have this problem. Okay, first problem. A culture initially has a number n sub 0 of bacteria. Okay, so n sub 0 will represent the number of bacteria initially, or at time is equal to 0. Now at time is equal to 1 hour. The number of bacteria is measured to be 3/2 n sub 0. If the rate of growth is proportional to the number of bacteria present, determine the time necessary for the number of bacteria to double and triple, okay? So you are asked here to determine the time that the number of bacteria will double, and letter B, it will triple. Okay, so let us solve this first problem. Okay, so you first write the given. So here we represent n as the number, or we put n as the number of bacteria present. Okay, and we also have the rate of increase or rate of growth. So it is dn over dt. So this is the rate of growth of bacteria, or rate of increase. Yeah, growth of number of bacteria. Now, so we have, you're going to read the problem. So we have, you can come up with these conditions at, at time is equal to 0, or initially, the number of bacteria is n sub 0, okay? And after 1 hour, the number of bacteria is 3/2 that of n sub 0, so it actually increased. Now, you are asked to solve for, first one is the time at which the number of bacteria will double, so that's 2 times n sub 0. And letter B, you're asked for the time at which the number of bacteria will triple, or 3 times n sub 0. Now for our solution, okay, so we start with, of course, what is being stated in the problem. So it says that The rate of growth is proportional, so that's K, to the number of bacteria present. So that's dN over dt equals K times N. So this is actually separable. We can put the equation into like this. So dN over N equals K times dt. And then we can integrate both sides of the equation, giving us on the left-hand side, you have ln of N is equal to K times T plus the arbitrary constant C, or we can simplify this solution to, or by adding ln C. Now, taking the anti-ln of both sides of the equation, we have N equals, okay, remember that if you take the anti-ln, on the right-hand side will give us e raised to kt times e raised to ln of c. Now, e raised to ln of c is equal to c. That's why we have c times e raised to kt on the right-hand side of the equation. Now that we have this solution, we are going to use the conditions to solve for the arbitrary constant c. Okay, so firstly, we have at time is equal to 0. The number of bacteria is represented by n sub 0. Now we plug it in here in this solution. So we have n sub 0 equals c times e raised to k times 0. Now you know that k times 0 is 0 and e raised to 0 is equal to 1. That's why the value of arbitrary constant is equal to n sub 0. Now you plug it in this solution. Now we have n equals n sub 0 e raised to k times t. Now we are going to use the next condition to solve for the value of k. So remember, k will be positive if it's growth. So we're expecting to have a positive k in this problem. Now we apply the condition. So n is equal to 3 halves n sub 0 equals n sub 0 e raised to k times time, which is equal to 1. Now we can cancel out n sub 0, both sides of the equation. And then we take the ln of both sides of the equation since we are going to solve for k. Okay, we get the inverse actually. So this is, this ln of e raised to k is similar to k times ln of e. And ln of e is equal to 1. That's why we have the value of k equal to ln of 3 halves. So you can use ln of 3 halves to represent k, or you may represent that by taking the value of it in 4 decimal places. Since this is an intermediate solution, so you cannot round off into decimal places. So the minimum number of decimal places here is 4 decimal places. In that case, or you may use L in the 3 halves. Now we can see that k is positive, so we rewrite our solution. This is n equals n sub 0 e raised to 0.4055 times t. Now we determine the value of the time at which the number of bacteria will double, or 2 times the initial, or 2 times n sub 0. So we use this solution n equal to n sub 0. So you plug it in there. The value of n, which is 2 times n sub 0, equals n sub 0 e raised to 0.4055 times t. Now we can cancel n sub 0. And then we take the ln of both sides of the equation. So we have ln of 2 equal to ln of e. So why do we do this? For us to be able to solve for time. Now we copy again, ln of 2 equals to ln of e raised to 0.4055t, or we can rewrite that into 0.4055 times t times ln of e, and ln of e is equal to 1. Now we can determine the time, which is ln of 2 divided by 0.4055. As we have the time at which the number of bacteria will double, and that is equal to 1.71 hours. Okay, so any question here? Okay, none. Let's proceed to letter B. We are to solve for the time at which the number of bacteria will triple, or 3 times the initial number of bacteria, or n sub 0. Now we utilize again the solution equal to, okay, again, n is equal to n sub 0 e raised to 0.4055 times t. So we plug it in that solution. So we have 3 n sub 0 equal to n sub 0 e raised to 0.4055 times t. We cancel n sub 0, and then we take the ln of both sides of the equation. Now we have ln of e on the right-hand side raised to 0.4055 times t. And we can determine the time here. Okay, do you have any questions? So ln of v again is equal to 1. I'm dividing both sides by 0.4055, or ln of 3 halves. It's similar to that. So T is equal to ln of 3 divided by 0.4055, as we have the time, which is equal to 2.71 hours. So this is the time at which the number of bacteria okay, will triple. Okay. Any questions regarding the solution? Anyone? Anybody? Clear? Any clarification? None? Sure? So we can move on to the next problem if you don't have any questions. So just a reminder again, the value of our K here is positive since the problem is about growth, or it's increasing. So remember, we use the first equation, the growth equation. Now for our next problem, we'll be using the same equation, but it's a decay problem. Okay, so here it says that a certain radioactive material is known to decay at a rate proportional to the amount present. Okay, let me check if this class is being recorded. Yeah, I think it's recorded. Anyway, so let's continue. If initially there is 50 milligrams of the material present, and after 2 hours, it is observed that the material has lost 10% of its original mass. Now we are to find an expression for the mass of the material remaining at any time t. And you also have to find the mass of the material after 5 hours. And letter C, you are to find the time at which the material has decayed to 1/2 of its initial mass. Or sometimes it is stated as the half-life. Okay, so when we say half-life of the material, it is the time at which the material, okay, has decayed to 1/2 of its initial mass. It became 1/2 of its original mass, or maybe original amount. So that's the other term for this item here in letter C, the half-life, or the time that the material will become 1/2 of its original mass or amount. Okay, so are we clear here? Now let's go to the next page. Again, we will be utilizing this same equation, but we are expecting to be having a value of K which is equal to a negative value. Okay, so firstly, you have to write the given. So we represent M as the mass of the material or the radioactive material, and dm over dt is the rate of decay of that radioactive material. Okay, so I'm just showing you that so that you can be able to write your equation later. So initially it says that at time is equal to 0, the mass of the radioactive material is 50 milligrams. Now it says that after 2 hours, so the mass of the material actually has lost 10%. So it means that we are to subtract from 50, okay, 10%. So 50 times 0.1, that's 10%. And then subtract it to 50. So we have 50 minus, that is 5. So we have 45 milligrams of the material after 2 hours. Or you can simply say the mass of the material is actually 0.9 of the original mass, which is 50 milligrams. And that is equivalent also to 45 milligrams. So it's either of the two. So for as long as it means actually the same, means the same. So we are asked here, okay, we have 3 items to solve an expression. So M as a function of time, or the mass of the material as a function of time. And letter B, you're asked to solve for the mass. So in this item here, we can utilize letter A to solve for the mass. Okay, since A is an expression of the mass of the material remaining at any time t. So B is the mass after 5 hours, and letter C is the time at which the mass will become 1/2 of the original or the initial mass, which is 50 divided by 2 is 25 milligrams. Okay, are we clear here? Any questions? None? Then let's solve. So again, I'll be using the same equations. The rate of decay is proportional to, so we have K there, to the mass of the material. So we separate the variables, and then that's it. We can integrate both sides of the equation, and then we have ln of m on the left-hand side, and you have k times t plus the arbitrary constant c, or you can put ln of c to simplify the given solution. Okay, again, so we utilize the same equation as of the first problem, but we're expecting to have a negative value of the k since it is decaying or decreasing or decomposing. Okay, so for us to be able to solve for m, we get the anti-ln of both sides of the equation. That's why we have m equal to c e raised to kt. So this equation or this solution does not represent decay because the value of k should be negative. So that's why we are going to use the conditions to solve for the constant, arbitrary constant, and the value of k. So here we plug in 50 milligrams to that solution, and time equal to 0. That's why we have c equal to 50. That's why our solution now is m equal to 50 times e raised to kt. Now the next condition will lead us to finding for the value of k, which we expect to be negative. So we plug it in that solution. So 45 equals 50 times e raised to k times 2. And then, okay, we divide both sides by 50. So we have 45 over 50 equals e raised to 2k. And then to solve for k, we get the ln of both sides of the equation. So ln of 45 over 50 is 0.9 equals ln of e raised to 2k. So we can simplify that. Ln of e raised to 2k is 2k times ln of e, and ln of e is equal to 1. That's why the value of k is equal to ln of 0.9 divided by 2. Okay, remember that ln of a number less than 1 is actually negative. So it's negative 0.0527 rounded off to 4 decimal places. Okay, and okay, that's it. We rewrite the solution. So the mass of the material at any time t is actually 50 times e raised to minus 0.0527 times t. So this is the mass of the material at any time t. This is the expression that we are looking for. So you just rewrite this, and then we enclose this to a box. Now letter B, we are asked to solve for, anyway, do you have any questions here? None. So we use the equation in letter A to solve for the mass after 5 hours. So we plug it in that solution. So m is equal to 50 times e raised to minus 0.0527 times 5 hours. Okay, using your calculator, so we can now have the mass, which is, it should be less than 50 since it's decaying. So we have 38.42 milligrams. As you notice, so after 2 hours, it says there that the mass has lost 10%, so it's 45 milligrams. And after 5 hours, it became 38.42 milligrams. Now, the next item is we are to solve for the time at which the mass will become 1/2 of its initial value, or that is 25 milligrams. We're expecting to be greater than, to have a time greater than or mas mahaba pa, diba? So we are going to use the equation in letter A, the mass at any time t. So you plug it in that solution. So we have 25 equals 50 times e raised to minus 0.0527t. Then we divide both sides by 50. So we have this resulting solution, and we take the ln of both sides of the equation. So ln of 25 over 50, or ln of 0.5, is equal to ln of e raised to minus 0.0527t. Then we have t equal to ln of 0.5, and divide both sides by minus 0.0527. Again, ln of a number less than 1 is negative. That's why negative over negative, we have a time that is in positive, okay, sign. 13.15 hours is the time at which Okay. So 13.15 hours is the time at which the number or the mass of the material became okay one half of its initial value. Okay. So that's it. So we were able to prove that in decay process, the value of K is negative. That's why this is your particular solution, or we call this the expression at any time t. And if it's a growth problem, the value of K is positive. Just a few reminders. Okay, any question, guys?
Sir, tanong lang po, sir.
Go.
Yung formula po ba na C e raised to KT, lagi po ba yun yung gagamitin namin or may instances po na hindi po yun yung formula na gagamitin?
Mm. C e raised to KT. Tama ba? Yeah. Yun actually yung formula. Pero pinanggalingan nun is a differential equation, right? Kaya lagi kong pinapakita yung differential equation bago nag-arrive dun sa mismong formula na C e raised to KT. So that's actually the shorthand. So yung iba, lalo na ngayon, di ba? Dahil sa online na tayo, so you'll be utilizing that. Unless, di ba, I'm going to ask you to show your complete solution. So you have to start with a differential equation. But, you know, pag nasa board exam yan, tinuturo na lang yung calcu technique, di ba, or the shorthand method. So you utilize C e raised to KT for that matter. So it's either you. Okay. Direct ka na kaagad, solve for the arbitrary constant and then the value of K using the conditions. So importante pa rin na alam mo kung paano siya isulat yung given muna. Kasi in that way, malalaman mo kung ano yung mga conditions na gagamitin mo to solve for the constants. Okay, so that's the purpose of this, uh, of me showing the entire solution.
Thank
Okay?
you po, sir.
Importante alam niyo yung paano magsimula, kung saan ang galing yung C e raised to KT. Okay? Clear?
Okay po, sir.
Ganun. So wala nang instance na iba pa. So yun talaga yung kalalabasan kapag growth equation or decay equation. So mangyayari lang na e raised to minus KT yan kapag decaying and e raised to positive KT kapag growing or ma-increase. Any other questions? None? Okay, I think we're ready to proceed to the next example. Okay, the population of a certain country is known to increase at a rate proportional to the number of people presently living in the country. If after 2 years the population has doubled, and after 3 years the population is 20,000, find the number of people initially living in the country. Okay, so this is a population growth problem. Now, although this, the solution that we are going to have for this problem is an approximation, but still, uh, we are somehow projecting or what we are expecting to have. Okay, the number of people initially living in the country. Okay, so let's play this one. Firstly, so you have to write the given. So we represent the population by letter P. So P being the number of people presently living in the country, and you have dP over dt as the rate of increase or the rate of growth of the number of people in a country. Okay, so now we are going to write the initial conditions. It says that, okay, at time is equal to 0, the number of people, we don't know yet the number of people initially living in the country, so we are represented by P sub 0. And after 2 years, the number of people has doubled, so you put that as 2 times P sub 0, 2 times the initial. And after 3 years, the number of people is 20,000. Now, what is the population initially, or the number of people living in the country at time is equal to 0. So we write the equation. So the rate of growth of the number of people presently living in the country is proportional. So you have k times p, proportional to the number of people presently living in the country. So by separating the variables, so this actually, is showing you that we have utilized variable separable in solving this differential equation. Very simple problem. Okay, elementary application. So we have taken the integral both sides of the equation, and then we came up with this answer by taking the anti-ln. So P is equal to C e raised to k theta. So that's yung na-mention kanina ni Mr. C e raised to k theta, diba yung naging result. So now if you start by this solution, so you make sure that you know the conditions that you are to apply. So we have initially, so a time is equal to 0, P is equal to P sub 0. So therefore the value of C is equal to P sub 0. That's why we have this solution, P equals P sub 0 e raised to KT. Now we are going to utilize the next condition, at time is equal to 2, or 2 years, number of people has doubled. So you plug it in this solution. So 2 times P sub 0 equal to P sub 0 e raised to K times 2 years, or times 2. We can cancel P sub 0. Then we take the ln of both sides of the equation to solve for K. So again, this is a growth problem. So we expect that K is positive. So K is equal to ln of 2 over 2. So you can utilize that exact value, or you can put it in decimal as long as it is in 4 decimal places. Okay. Now, so since we have the k now, so we rewrite the solution. This is p sub 0 e raised to positive 0.3466 times t. This is our solution, or the expression of the population at any time t, or the increase of population at any time t. If you're going to graph this, it's actually exponential, since you have there e raised to 0.3466. Now we apply the condition to solve for the value of p sub 0. So we have 20,000 equals p sub 0 times e raised to 0.3466 times the time is 3 years. So yung kasi yung time na magiging 20,000, yung number of people. So you just multiply that by 3. And now we solve for p sub 0. So p sub 0 is equal to 20,000 divided by point, or e raised to 0.3466 times 3. Using your calculator, we can determine p sub 0 equal to what? You can use your calculator there. Anyone? The answer here is actually, if you're going to use the exact value, so it will become 7,070. Okay, let me check with my calculator. So if I'm going to use k equal to ln of 2 divided by 2, so that is 0.34657359. And I'll be using that, I'll be multiplying that to 3, and then put that in exponential function. So e raised to that value, e raised to answer, I have 2.82, and then I will use this as to divide 20,000 divided by answer. So it's actually 7,071.0678, right? So this is the result of utilizing the exact value. So if you have this result na 7,071.06, your answer should be rounded up, since we're talking about number of people, or population. Okay, since I have utilized this value of k, which is 0.3466, my answer is 7,071. Okay, same lang yun. So any clarification here? So the unit, of course, 7,071 people, okay, who are initially living in that country. So ganun yan. So after 3 years, imagine naging 20,000 na. So yan yung parang, that's a simple illustration or problem to show you population growth. Okay, any questions?
Wala naman po.
Okay, then let's proceed to the next application. Okay, another elementary application for part 1 that we are going to solve is Newton's law of cooling. So this kind of applications, we can actually use the separable dE in determining the solution. Okay, so the idea here is, okay, Newton's law of cooling states that the rate of change of the temperature of a cooling body is proportional to the difference between the temperature of the body and the constant temperature of the medium surrounding the body. So take a look at the illustration here. So this is the behavior of, or how the temperature cools down or decreases. And this is how the temperature increases. Okay, so you have this T sub m. What is this T sub m? This is actually the temperature of the surrounding medium. That's the constant temperature. Okay, so as you can see, or as you noticed, the initial temperature or T sub 0 or of a body or substance or anything. So pag nilagay mo siya sa isang room na may constant temperature, okay, if it's, for example, the temperature of that body or thing is less than the temperature of the constant temperature. So if you put that body into a room with constant temperature, which is higher, so mag-increase yung temperature, right? So ito yung kanyang characteristic or itsura ng graph natin. Now, if you put um, a body or thing in a constant temperature, which is less than that of the temperature of the body, so the temperature will decrease. Okay? So ganun lang yung simple na explanation dyan. Okay. Nakuha nyo na or nagets nyo ba? Okay. Ano pang isa pang example? For example, ano yung mga usual problems dito na sinosolve? Like, solve natin for yung first problem. If you want to bake something, di ba? Kunyari, magbe-bake ka or magro-roast ka. Ayan. So, initially, for example, the temperature of that roast is 10 degrees Celsius, for example. And then you will put that roast in an oven na merong constant temperature. For example, since you are to bake that, gawin natin 300 degrees Celsius yung temperature ng oven. So if you put that roast into an oven with a constant temperature na 300 degrees Celsius, so we're expecting that the temperature of the roast after a certain time will actually increase, right? Because the temperature of the roast is 10 degrees Celsius and you put that in an oven na mataas yung temperature niyan, yun yung limiting temperature. So pag nilagay mo dyan for a longer period of time, so it will actually reach somehow the temperature, the constant temperature, right? Okay, masusunog na yung roast mo, di ba? Nilagay mo yun forever. Anyway, so yung point dito is hindi talaga sobra, di ba? Doon sa limiting temperature. Nakuha niyo ba yung punto? Yan, asymptotic siya, di ba? Hindi talaga siya nag-touch dun mismo sa constant temperature. Pero somehow close to that kapag masyadong matagal na nilagay. Kunyari, naglagay ka ng, nagawa ka ng ice, di ba? So yung ice tubig, ang tawag dito. Yeah. Di ba merong lagay ng ice cubes, no? Nilagyan mo yan. Nilagyan mo ng tubig. Nilagay ng ice cubes. Nilagay mo sa freezer. So initially, for example, yung temperature ng tubig is 20 degrees Celsius. Nung nilagay mo dun sa refrigerator, for example, na ang temperature ay, yan, sabihin natin kasi freezing point ng water is 0 degrees, di ba? So nilagay mo dun sa mismong freezer na 0 degrees Celsius. Okay, pag nilagay mo dyan sa matagal na panahon, yung lagayan ng ice, yung gawaan ng mismong yelo, di ba? For a period of time. Kunyari, 3 hours. Mag-freeze na yung mismong water mo at somehow ma-reach na yung 0 degrees Celsius. Right? So, ganun. Hindi siya lalagpas, hindi siya magiging negative. Nakuha niyo yung point? Hindi pwede siyang, kasi yung limiting temperature mo lang, yung constant temperature ng pinaglagyan mo ng mismong object na yun or ng mismong thing na yun is, yun lang, di ba? 0 degrees Celsius. Pero kung negative yan, so, maaaring ma-reach na yung gano'n na value ng temperature. Okay? So, this is the equation. So, ito yung equation describing the Newton's law of cooling or defining the Newton's law of cooling. It says that the rate of change of a temperature of the cooling body, so hindi lang naman nag-refer dun sa cooling or sa pag-decrease ng temperature, but also it refers to the heating or pag-increase ng temperature. So the rate of change of a temperature of the body, may it be cooling or heating, is proportional. So you have this K to the difference between the temperature of the body and the temperature of the medium of the temperature of the medium surrounding the body, or this is the constant temperature. Okay, so ito yung equation natin. This is differential equation, right? So it says here that K is, of course, the constant of proportionality. So you may or may not put negative here. Nilalagay lang yung negative dyan para maging positive siya sa cooling process. But anyway, so that's it. Now, let's go to solving this first problem. Ito na yung sinasabi ko kanina. A 2 kilogram roast, initially at 10 degrees Celsius, is put into a 190 degrees Celsius oven at 5 p.m. So, 5 p.m. nilagay mo yung roast na kung saan yung temperature ng roast. So, initially, pag sinabing initially, at time is equal to 0, yun yung starting ano mo eh. So, time 0. Nilagay mo sa oven na may constant temperature na 190 degrees Celsius. And, of course, what will you expect? Kapag iniwan mo yung roast dyan, for example, di ba, after a few minutes, syempre you expect that the temperature of the roast will increase, right? So, hindi pwedeng mag 9 degrees Celsius yan, di ba? Pag nag 9 yan, ibig sabihin, hindi gumagana yung oven mo or baka reverse yung ginagawa niya. Okay. So it is found that the temperature of the roast, temperature represented by T, ayan, is 50 degrees Celsius after 25 minutes. Oh, ganun pala. So 25 minutes after or later, yung 10 degrees Celsius na roast ko naging 50 degrees Celsius. Okay, now, when will the roast be 65 degrees Celsius? So ano daw yung, anong oras naging 65 degrees Celsius yung ating roast? Siyempre, you expect na dapat mas ano pa to, mas greater than 25 minutes, 'di ba? Mas ano pa siya, mas matagal pa. Right? Kasi mas mataas yung temperature, right? Okay, so now let's solve this problem. So we'll start by writing the given. Okay, wait a moment. Maingay. Okay, so you write, ano yung T na yan? T will in capital letter or big letter T will represent the temperature of the roast. And of course, we have this rate of change of the temperature of the roast. Hi guys, kumusta kayo? Gising pa ba kayo? Baka nakatulog na kayo.
Gising ba po?
Gising pa po. Sumagot talaga. May natutulog ba? Okay. Now, so we write also, alamin mo kung ano yung constant temperature dyan. So clear naman sa atin na 190 degrees Celsius is the constant temperature. Yun yung temperature ng oven na paglalagyan mo ng roast. So initially, at time is equal to 0, the temperature of the body, or in this case, yung roast natin, we don't know kung anong klaseng roast chicken, roast beef ba yan, okay, is 10 degrees Celsius. And after 25 minutes, the temperature of the roast is 50 degrees Celsius. Okay, now, the question is, when will the roast be 65 degrees Celsius? So ano yung time daw that the roast Okay, that's it, 65 degrees Celsius. Now, in our solution, Newton's law of cooling states that, ano ulit? The rate of change of the temperature of the cooling body is proportional. That's why you have K. So dt with respect to time is equal to K, and proportional to the difference between the temperature of the body and the temperature, the constant temperature of the medium surrounding the body. Okay, so as you can see, hindi na ako naglagay ng negative dyan. So, basta, okay, let's proceed here. Now we apply now, ano yung T sub M natin? So 190 degrees Celsius. Now we can separate the variables here, right? So dt over T minus 190. And on your right-hand side, andito yung time natin, yung variable na small letter t. Then we integrate both sides of the equation. This is ln of the temperature minus 190 equals k times t, small letter t, plus, of course, the arbitrary constant c, or ln of c, to simplify this solution. And then we take the ln of, tatanggalin natin yung ln, di ba? So we get the anti-ln of both sides of the equation. So we have this e raised to kt plus ln of c. Okay, and you know that on the right-hand side, e raised to kt times e raised to ln of c will give us what? c e raised to kt. Okay. Okay, so far guys, na-follow nyo pa rin ba? Sundan nyo yung solution?
Opo.
Apo.
Medyo mabagal na itong pagsosolve ko dito. Okay. Now, so you rewrite now. So e raised to ln of t minus 190 is equal to, wala nang ink yung marker. Anyway, so this becomes t minus 190 equals c e raised to k times t. So this is now your solution. Or we can transpose minus 190 to the right-hand side. So you have the temperature equal to 190, and 190 is the constant temperature yun, di ba? Do you remember? Now we use the initial condition, and na T equal to 0, the temperature is 10 degrees Celsius, to determine the arbitrary constant C. So you have 10 equals 190 plus the arbitrary constant C, e raised to k times 0. So e raised to 0 here is equal to 1. Now, the value of C is equal to what? Negative, ang yung 190 transpose mo sa kabila, maging minus 190 plus 10, you have minus 180. Okay? Now, we plug it in the solution above, which is T equals 190. Sulat natin. 190 minus 180 e raised to k times t. So this is now our solution. Now we use the next condition to solve for the value of k. So after 25 minutes, the temperature becomes 50 degrees Celsius. So you plug it in that solution. So 50 equals 190 minus 180 e raised to k times 25 minutes. So again, be consistent with your units. Kung for the entire solution, di ba, you utilized minutes, dapat minutes lahat. Kung hours, hours lahat. Okay? And here we are going to solve for, okay, let's move it a little bit faster here. Maybe we can rewrite. Okay, so transpose this term to the left-hand side. That's why you have 180 times e raised to k times 25 equals 190 minus 50. And that is 140. And then 140 divided by, we divide both sides by 180. Okay, let's move. Okay, we use a different marker here. So e raised to k times 25 equals, so we divide both sides by 180, that's why 140 over 180. And then to solve for k, we take the ln of both sides of the equation. That's why we have 25k equals ln of 140 over 180. Then you have k equals, okay, we use our calculator to solve for k. And what do you expect? Negative yung value ni k dito because yung ln ng number less than 1 is negative. And then divide that by 25. So you have minus 0.0101 for decimal places ulit. So sa lahat ng computation nyo, if you are planning to round off intermediate values, dapat naka 4 decimal places at least, okay? And then your final answer in 2 decimal places. So naka-specify naman yan sa mismong exam. So here we have now the solution equal to, or t is equal to 190 minus 180 e raised to minus 0.0101 times t. So we utilize ito yung expression kumbaga na kapag given ka ng temperature, masolve mo yung time. Pag given ka ng time, masolve mo yung temperature. Okay, so now we can solve for the time at which the temperature will become 65 degrees Celsius. So 65 equals 190 minus 180 times e raised to minus 0.0101 times t. Okay, iba dyan ang ginagawa nila, input sa calculator, shift solve. Tara! Ganun. So ang ginawa ko dito, transpose ko muna sa left-hand side, itong merong unknown, which is yung t natin, and then transpose yung 65 sa kabila. So 190 minus 65. And, okay, let's erase this first. And then we start writing our, here. So 180, well, what happened? Lekta na. Erase 2 minus 0.0101 times t equals, nag-lunch na kayo, guys? 190 minus 65. Ang epic lang, no? Kinakausap ko yung sarili ko. Anyway. ln of, so para makuha natin yung t, kailangan clear natin yung exponential function dyan. And ano yung inverse ng exponential, di ba? Logarithmic function. Ano inverse ng logarithmic? Exponential. So yun lang naman yung gagawin natin. So 190 minus 65 is 125 divided by 180. Take the ln both sides of the equation. So you have minus 0.0101 times t. ln of v is equal to 1. So, ganun na. So ln of 125 over 80. Or we can divide both sides by minus 0.0101. Bulahin na natin yan sa left-hand side. So I divide both sides na natin. Tandaan niyo ha, ln of a number less than 1 is negative. Kaya negative over negative is positive yung time natin. Okay? Using your calculator, the value of the time at which the roast will become 65 degrees Celsius is, okay, calculate, 36.10 minutes. Okay, tandaan niyo ha, yung unit is in minutes. Now, di ba nagsimula tayo ng 5 p.m. So, anong oras magiging 65 degrees Celsius? So, 5 p.m. plus 36. Yan. Ganun lang. So, at 5, 36.1 p.m. the roast will be 65 degrees Celsius. Okay? Any question? This is our final answer. Okay. Questions? Clarifications? None? Marunong ba kayo mag-solve ng definite integral? Guys?
Opo, sir.
Opo.
Okay, mabuti naman. How about the others? So, kaya ninyong isolve to?
Kaya po.
Yes, great job. So mamaya may special class pala ako. So if you feel like okay na kayo sa application, so pwede naman kayong hindi umattend na. Okay? Pwede
Sir,
na kayong
recorded po din po yan.
hindi. Hindi, tingnan natin. Pwede naman i-record. Kasi parang maging informal siya. Part of it, parang informal because I'll be accommodating some of the questions. Pero mag-solve ako ng problems for sure. Okay. Mag-solve ako ng problems like yung, but not about yung, siguro similar problems dun sa quiz ninyo. I'm not really, kasi hindi ko pwedeng ipakita pa yung solution ng sa quiz. So, to prepare you for the prelim exam. Your prelim exam will be on Tuesday. Okay? Ang oras is 2:30 to 4 p.m. Okay? Sige. Kasi alam ko may mga issues ngayon sa sa internet, 'di ba? Mabagal yung internet, yung iba hindi nakakapasok, right? Okay. Sige. So meron pa tayong isang problem. So I want you to take out a piece of paper, clean paper, and ball pen. Try nyo itong isolve. Mhm. Now, I'll be showing you a different way to solve this problem. So kanina, medyo mahaba yung problem. Ito, bawasan ko ng konti. Gawin ko na lang na hindi ko na isosolve yung mismong arbitrary constancy. K na ako diretso. Sige. Simulan na lang natin. So dito, yan. Mag-solve din kayo, sabihin niyo ako mag-solve. Pero ang gagawin ko kasi dito is, yung nag-apply ako ng limits. Alam niyo ba yon? Yung pag definite integral may limits, di ba? Paano ba nag-apply ng limits pag definite integral? Marunong ba kayo nun? Nawala na naman yung mouse ko. Where are you? Okay. Ayan. Di ba pag meron kang, for example, integral of x dx. Tapos may limit na 0 raised to, yung lower limit mo is 0, and upper limit mo is 1. Di ba sa calculator, kayang-kaya yan, di ba? Paano pag walang calculator? So integrate mo muna ito bago may apply yung limits, right? So you have x squared over 2. Pag definite integral, wala ka ng plus c dyan, di ba? So ganun yung gagawin ko din dito sa problem na to. Hindi na ako maglalagay na, hindi ko na solve yung c. Direct ako na sa limits. Yan. So 0 to 1. So paano nag-apply ng limits? Upper limit minus lower limit, right? So 1 squared is 1. So 1 half minus 0. So the answer is 1 half. Diba? Okay, alam niyo na siguro yan. Kaya tahimik na kayo. Sige, now, gawin na lang natin to. A metal bar at a temperature of 100 degree Fahrenheit is placed in a room at a constant temperature of 0 degree Fahrenheit. Okay, now after, so ano yung ating constant temperature dito? So ito lang natin, T sub m natin is equal to placed in a room of 0 degree Fahrenheit. Right? Nagsasolve ba kayo, guys?
Na-try po.
Yan, try nyo. Tapos, after 20 minutes, initial pala, so at time is equal to 0. Ano ba yung temperature initially? That is, the temperature of the bar is 100 degrees Fahrenheit, okay? Now, after 20 minutes daw, so at time is equal to 20 minutes. So take note, the time is in minutes. The temperature of the bar is 50 degrees Fahrenheit. So as you can see, nilagay mo, yung bar kasi is 100 degree Fahrenheit. Nilagay mo siya sa isang lugar kung saan, sa room na ang temperature is mas mababa sa kanya. Ibig sabihin, so bababa yung temperature ng bar mo. Pag iniwan mo dyan for a long period of time. Tingnan mo nangyari, di ba? After 20 minutes, naging 50 degrees Fahrenheit siya. Now, letter A, tinatanong tayo dito na yung, ano daw yung time that the bar will reach a temperature of what? 25 degrees Fahrenheit. And then letter B, we are asked here to find for the temperature of the bar, temperature of the bar after 10 minutes. Okay, take note nakalagay after 10 minutes. So, hindi naman siya na-mention na 10 minutes after nitong ibig sabihin kasi ito 10 minutes after the initial time. So, we're expecting to have greater than 50, right? Kasi 10 minutes ito. Unless pag sinabi na after an additional 10 minutes, so 30 minutes yun. So, yun yung isa sa mga pwedeng modification for this problem. Okay, now we are going to use the equation for Newton's law of cooling. It says that the rate, of change of a temperature of the cooling body, so dT over T, is proportional to the difference. So you have of the temperature of the body minus the constant temperature, and that is what? 0, right? So temperature, the constant temperature, so 0 siya. So we can now separate the variables here. So we have dt over t, and capital letter T, equal to k times dt. Okay. Now we integrate both sides of the equation. So ito, apply natin yung limits dito. So we are now going to solve for k here. So gamitin natin initial conditions, these two conditions, to solve for k. Again, so ito ang nasa right side mo. Since ang involved dito na variable is yung time, so dito yung limits mo dapat time, di ba? Itong t na to. Sa left-hand side naman, temperature, di ba yung involved na parameter dito? So your limits should be temperature. Nakuha? Guys, nasundan? Or nagsasolve din kayo? So ito yung gagamitin ko. So initially, so yung lower limit ko will be 0. 0 yung time. Ano yung corresponding na temperature dyan? Yun yung maging lower limit dito sa left-hand side. So 100 degrees Fahrenheit. Sa right-hand side naman, ano yung upper limit natin? 20 minutes, di ba? Kasi time naman pinag-uusapan dito. And dun sa kabilang side, since temperature ito, ano yung temperature corresponding to this time? That's 50 degrees Fahrenheit. So ayan, pwede mo nang masolve dito yung value and then masolve mo na rin yung k. Okay, pag meron na tayong k, ito tayo dito. Ayan, so calculator lang yan. So may value tayo ng k. Pag meron ka ng k, solve na natin yung time. So, ang mangyayari is the same equation. Wait lang. No, I didn't ask for this one. Anyway, basta ganun yung idea. Tayo na. Undo. Okay, here. So, may value ka na ng K. Tapos, the same equation, dt over, ayan, the temperature here is equal to, ayan, may value ka na ng K. Plug in mo dyan. Tapos, integral ng dt. So, yung unknown dito is yung time, di ba? So, yung lower limit mo will be 0. What's the, of course, corresponding temperature? So, you have 100. And then, pwede mong gamitin yung yung 20, pwede rin. Or pwede rin ito, 0. So, upper limit mo will be what? T. Kasi, yun yung aalamin natin. Ano naman yung corresponding na temperature kapag ito yung hahanapin natin. So, you have 25 dun sa left-hand side. Ayan, so we can actually solve now. Ano ba yung value ng K dito? Pasok mo yung value ni K. Ayan. Right? So, ito limit nito sa left-hand side mo, 100. Lower limit, upper limit mo is 25. So, yung time mo na makukuha is, yun na. So, parang ang mangyayari, yung sagot dito sa left-hand side, divide mo by K. Ganun. So, yung sagot mo dito, yun yung numerator dito. Tapos, yung denominator mo is yung value ni K. Yun na yung time natin. Okay, guys? Anong sagot nyo? Hello? Hello? Anybody there?
Sir, try lang, sir. Sir, try lang po.
Ano na? Yes.
Narinig po ako, sir.
Yep.
Ano po, sir? 39.95 minutes. Ay, minutes tuloy. Time pala yun. Time daw. Tama. Time naman. Mali po, sir.
Okay, ano ulit? Sorry. May kausap lang ako.
39.95 minutes, sir.
Very good. Check natin. Ayan, 39 point. Ano yung letter B? (70.5°F). Okay? Clear muna natin kasi medyo magulo yung ano natin. So ito yung sagot, guys, just in case that you want to know the answer for letter A. The time is 39.6 minutes or closer to this kung di ka man nag-round off or nag-round off ka. So at least 39 minutes. And the temperature after 10 minutes is 70.5°F. So tama lang din na greater than 50 siya and less than 100 of the initial temperature of the metal bar. Okay? Are we all good?
Yes po.
So okay lang, no? Madali lang. If you have no questions, then thank you for being here. I hope you learned something today. Okay, so next time ulit.